Hi students, welcome to our YouTube channel again. So today our topic of discussion is freezing point and boiling point calculations. So here is our first question, that four liquids are described in the table below. Use the second column of the table to explain the order of their freezing point and the third column to explain the order of their boiling points. For example, select one in the second column here next to the liquid with the lowest freezing point. So 1 for the lowest, and select 2 in the second column next to the liquid with the next higher freezing point, and so on. In the third column, select 1 next to the liquid with the lowest boiling point, and then 2 for the higher boiling point, and then so on. Okay. So note the density of the water, that is 1.00 grams per ml. So we have four liquids. So the first of all, that is 5.6 grams of potassium hydroxide dissolved in 350 ml of water. The second liquid is 5.6 grams of sucrose dissolved in 350 ml of water, and 5.6 grams of HCl dissolved in 350 ml of water, and we have 350 ml of pure water. So first of all, like these are all non-volatile, I am going to write non-volatile liquids. So as you know that dissolving a non-volatile substance in a liquid lowers the freezing point. Like when we dissolve non-volatile substances in a liquid, then what happened? Here the liquid, it will lower the freezing point. Okay, and that is the first condition. When we dissolve the non-volatile substance into liquid, it will depress the liquid freezing point and elevate. The second one is here, and elevate the boiling point. Okay, so now here, like we know that the change in, like for example, I am going to write the del T F is equal to, like the freezing point depression and the boiling point elevation is the proportional to the total number of particles. The particles may be atoms, ions or molecules dissolved in each liter of the liquid. The more the particles per liter, the lower the freezing point and higher the boiling point. Okay. Now the fact is usually expressed in two equations. So the first equation is del Tf is equal to Kfm, while the second equation, that is del Tb is equal to Kbm. Okay, where the Kf equation can be used here. The Kf equation can be used to calculate del Tf, the change in the freezing point. Kf is the, what is Kf? Kf is the molar freezing point constant. Okay, and while what is Kb? Kb is the molar boiling point constant of the liquid, where M stand for the total molality of the solutes. So M stands for the total molality of solutes. Alright, now first of all, here, in short, to solve this problem, first you need to calculate the total molality of the solute of each liquid. So it means the first step is to solve this problem, you need to find the total molality of each solute, or you can say of the solute in each liquid. Okay, so now we need to find, for example, like here we have potassium hydroxide 5.6 grams dissolved in 350 ml of water. So as we know that to find the molality, first we need to find the moles of KOH. And remember, whenever you have to solve and you have to find the molality, so remember, like a solution made by dissolving, like for example 1 mole of NaCl or potassium hydroxide in 1 kg water has the total molality will be 2. Why? Because that having the two ions, for example here is potassium ion, positive ion, and as well as the hydroxide ion, that is negative. Alright. So similarly, a solution made by dissolving 1 mole of HCl, that also gives like 2 moles per kg. Why? Because 1 mole of hydrogen ion and 1 mole of chloride ion. So same happening here. First of all, we have 5.6 grams. We need to find moles. Okay. So 5.6 grams of potassium hydroxide. So first we need to divide it. When we divide, so then like the molar mass of potassium hydroxide, that is 56.1056. So we got 0.09981 moles. Okay, so as I already said that here are the two ions like potassium ion, you can see here, and hydroxide ions. So it means the mole will be like 0.09981 times 2. Okay, so that will equal to 0.1996. Okay, so that is the mole for like potassium hydroxide. Now we need to find the molality. For the molality, first we need to convert 350 ml into kgs. Okay, so for kgs you need to like multiply volumes times density, and density is 1 kg, like 1 grams per ml. So it means here we have 350 grams. When we convert it into kilograms, so we got 0.35 kg. Okay, so now we need to find molality here. So for the molality, that will be 0. like moles per kg. So it means here is moles are 0.1996 divided by 0.3500. Okay, so that will equal to 0.57 moles per kg. So that is our first molality of the, you can say, liquid, that is potassium hydroxide. Okay students, so now we need to find the molality of sucrose, that is C12H22O11, and the mass is, that is 5.6 grams of sucrose dissolved in 350 ml of water. So same process. So it means now I'm going to write here step 2. So here we need to find the moles first. So moles equal to mass divided by molar mass. So here the mass is 5.6 divided by the molar mass, that is 342.2965. Okay, so we got 0.01636 moles. Okay, so remember that here, like the sucrose that are like not like as ionic, or that have not ability to give like any protons. Okay, so it means like that is the moles for the sucrose. Now we need to find the molality. So first we need to divide the moles by kg. So here the molality will equal to 0.01636 divided by like 350 ml. So it means that should be 0.3500 kg. So it means here we have the molality of the sucrose, that is 0.047. Okay, and that should be in moles per kg. Okay, so that is your second, like the molality of the second solution. Alright, now we need to find the next one, that is for HCl. For HCl again we have, okay, here I am going to write again we have like 5.6 grams of HCl dissolved in 350 ml of water. So here we need to find the moles first. 5.6 divided by like 36.461. So we got, that is the molar mass. So we got 0.1536, and as we know that when the HCl dissociates, so it will give hydrogen ions plus chlorine ions. So it means it should be 0.1536 plus 0.1536. So we got the total number of moles, that equal to 0.3072 moles. Okay, so now we need to find the molality. For molality we need to divide 0.3072 divided by 0.3500, and we got 0.88 moles per kg. Okay, so that is over. Like the third molality. Alright, and for like the 350 ml of water, so then the molality will equal to 0. Okay, now here we need to write, as we know that like the potassium hydroxide, that is equal to 0.57 mole, okay, mole per kg Okay, that is for the potassium hydroxide, the molality. Okay, now for the sucrose, that we got 0.4 0.047 mole per kg. Okay, now for HCl, that should be 0.88 mole per kg. Okay, and for water that would be 0. Okay, so these are the total molalities in mole per kg for these four solutions. Now you can see here like 0.57 is here, and for sucrose that is 0.047, and for HCl that is 0.88. Okay, now remember that using this information and the fact that the higher the total molality, the lower the freezing point. Okay, the higher the total molality, the lower the freezing point, and the higher the boiling point. So it means you can say that molality is inversely proportional to freezing point, while molality is directly proportional to boiling point. Okay, for example, here the highest molality here is for HCl, that is 0.88. So it means that the freezing point will be lowest. I am going to write here 1. Okay, now and the highest the molality, it means that the highest the boiling point. So here I am going to write 4. Okay, now the next one, that is the lowest the molality, the highest should be freezing point. So here the lowest will be 0. It means that is the highest freezing point, that is 4, while the boiling point that should be 1 here. Okay, it means I am going to write here, let me write it, that is lowest. Okay, and while that is highest. Okay, so same happening here, that is highest. Let me copy that. Okay, and here that should be lowest. Okay, now here when we compare 0.57 and 0.47, so 0.57 is the greater, so it means there should be number 2 here, and there should be number 2, while the 0.047, that is here number 3, the highest, second most highest. Okay, while here in like the column of boiling point, so there should be 3 because that is higher molality as compared to sucrose. So here you need to write 2. Okay, so that is the way in which you can solve these problems by using molality and by comparing these molalities with freezing point and boiling point. Okay, so here that is the end of this question. I hope you would like our video. If you like it, then kindly to subscribe us and share our channel. We'll see you in the next video. Goodbye.